Dear student, today we are going to start the second part of lesson number 5, that is data handling. In the last part, we have learned about how to prepare the group frequency table. To prepare the group frequency table, we have to find out the class interval. We have discussed about class interval, class size, and also the new word, that is class mark. So today we are going to start about the new word that is the histogram. Today we are going to start the new word, that is histogram. Histogram is a new word for the data handling. So in the histogram, the definition of histogram has histogram. We have already studied about the bar graph and how to use and to represent the data. To represent a group frequency table, we use the histogram. Histogram means to represent the group frequency table, we use the histogram. Okay. Now we should take one definition of histogram. Let's say that's histogram. Histogram is a diagram consisting of a rectangle whose area is proportional to the frequency of a variable n, whose weight is equal to the class interval. This is the definition of the histogram. Histogram is a diagram consisting of a rectangle whose area is proportional to the frequency of the variable and whose weight is equal to the class interval. Okay, so here also it's mentioned that it is to represent the group frequency distribution. So there is another definition of histogram also for the histogram. To represent the group frequency tables, frequency distribution, graphically we represent the group of the observation, that is class interval, on the horizontal axis, and the frequency of the class interval along the vertical axis. Also, there is no gap between bar. This graphical representation of data in this manner is called histogram. Here is also another example, another definition. Okay, then what is a, let's see what are the uses, why histogram has been used. Let's see. That is the definition of the histograms and why histogram is used. Histogram is used for what? For variable whose values are numerical and measures on an interval scale. It is generally used when dealing with large data offset, that is greater than 100 observation. Okay, see, histogram is used for a variable whose value are numerical and measures on the interval scale. It is generally used when dealing with the large data scale, that is greater than 100 observation. So that is why here also to represent a group frequency distribution we use histogram. So where histogram is used, when the numbers of the observation are very large, at that time histogram has to be used. And what is the definition of histogram? A diagram consisting of a rectangle whose area is proportional to the frequency of the variable and those wide is equal to the class interval. Okay. So next we have, this is the diagram, this is the definition, and this is the uses of the how, where, and why it is used. Okay. Now let's continue. This is a group frequency distribution of population of the, this is an example. Okay, let's see here. To make a histogram, this is the step to draw the histogram. To make a histogram, we draw two axes, that is like x-axis and the y-axis and x-axis. Okay, now we choose a suitable scale for this is to is something this is equal like bar graph what we have done, what we have drawn. Okay, the scale here, the scale of x-axis and y-axis need not to be same in the histogram. It should not be same, but whereas in the bar graph it should be same. Okay, bar graph and the difference between the bar graph and histogram is in the next we will learn here. What are the difference between the bar graph and histograms? Say difference between a bar graph and a histogram. In a bar graph, the bar are at a distance from one another, while in the histogram the bar touch one another. In the bar graph, the distance from one another. Okay, there is a distance between the bar graph, while in the histogram the bar touch one another. Means in the histogram there is no gap between the two bars. Point 2. In a bar graph, we generally have a scale for either x-axis or y-axis. Generally, x-axis as a vertical bar and more popular. But in the histogram, we have scale of both x-axis and the y-axis, and both scale need not be same. Whereas in the bar graph, the scale is generally we use scale of the x-axis, the vertical one. But whereas in the histogram, both axis has a scale, and both scale need not to be same. The third one is in a bar graph, one axis may not have numerical value, but have name, subject, flavor, etc. Suppose when we draw the bar graph, we put in the horizontal, we put the number, name, or subject, or favor. In the vertical, we put the numerical value along it. But in the histogram, we display numerical value along both axes. Whereas in the histogram, we display both numerical. This 1, 2, 3, these are the difference between the histogram and the bar graph. This 1, 2, 3, there are 3 points. These are different between the bar graph and the histogram. Now, how to draw the histogram? To draw a histogram, we use the following step. See, the first step, what we have to do is we draw a two perpendicular axes. First we have to draw two perpendicular, just like that we have drawn the bar graph. Okay, second one is we mark the class limit on the horizontal. We should put the class limit on the horizontal axis. And number 3, we mark the frequency on the vertical axis. In the point number 4, we construct the rectangle packing class interval as the base and corresponding frequency is the height such that the rectangle thus its other. This is a rule, this is a step how to draw a histogram. We draw two perpendicular axes. We mark the class limit on the horizontal axis. We mark the frequency on the vertical axis. We construct the rectangle taking class interval as the base and a corresponding frequency as the height such that the rectangle thus its other. Now let's see one example here. See, this is an example how to draw the histogram, and this is also another set of rules. See, this is a histogram. This is an example given in the another exercise here. So according to this class interval, this histogram has been drawn. So let's see here. To draw two axes, here is y-axis and here is x-axis. Okay, along the x-axis we mark the class interval here. In this side we will mark the class interval and the class interval so on. Note the king, K-I-N-K, between 0 and 80 on the x-axis. Here, look here. There is a one symbol, zigzag symbol. We call it kings. Okay, this indicates that the distance from 0 to IT is not shown completely, because here in this frequency tables, here the number from 0 to IT is not shown clearly. So if there is no number between 0 and 80, then we have to put the symbol of king. Okay, here look here. Here in this class interval, there is we have here in example number 4, here it start from 80. So here in this case it start from 80, so it cannot touch from 0 we cannot touch the 0 up to this. So we have to keep the gap. This gap, the zigzag gap, we call it king. Okay, so if this 0 to IT is there, then we have to touch this bar also. So here if there is no indication, this is the distance between 0 to IT, so we need to put the sign of king. Okay, then next on the x-axis mark the frequency. This is the frequency, this height, since the greatest value is 12 up to 12. We take the scale, and again we have to take the scale 1 unit of 1 unit here to here is 1 unit. Okay, 1 unit is equal to 2 student. Now construct the bar of the rectangle with the base as a class interval. This is the base class interval, and the frequency of the interval is height. This is height. Set it and set the rectangle, and then we have to set the rectangle. Notice how the scale of x-axis and y-axis are different. Okay, then histogram are used for summarizing the data. If histogram is given, certain useful conclusion can be drawn from this. So this is known as the interpretation of the histogram. This is how we have to draw the histogram. So now we will start. Now we will draw one histogram. Let's see. Here, this is an example. This is an example. The following table shows the mark of 35 students. This is a frequency. This is a group frequency tables. Here, this is a class interval, and this is a frequency. And the question is, draw a histogram to represent the data. We have to draw the histogram to represent this data, and also answer the following question: what is the class size? Which class interval has highest frequency? Find the class mark of this interval. So first, we are going to start to draw the histogram of this given data. Okay, let's check how to draw the histogram. Now there is no bar graph for me, so I have to explain here in in this paper. Okay, so first we have to draw x-axis. Here is x-axis. This is x-axis. We said that this is a x-axis, and here again that means that we have drawing about the next we have to draw the two perpendicular axes. So these are the two perpendicular axes. Yeah, this is a y axis. These are the two perpendicular. The joining point we call it, the meeting point of this two line we call it, this is a 0. Next we have to mark in the horizontal, we have to mark the class interval. In the vertical, in x-axis, we have to mark the frequency table. Let's see here. Here is the class interval is 0 to 10. Here will be, now this is a base, this will be the class interval. So we have to write first one, that is 0 to 20. Here is 10, 20, we write 30, 40 and 50. We call this is a marks of the student. Marks, we write here marks of student. This is a class interval. Mark of the student. Okay, 10, 20, 30, 40, 50, up to 60. Sorry. This is the mark of the student got by 35 students. Okay. Now again, here in the frequency, this side is a frequency. Frequency means number of the student. Number of the student. In the x-axis, and sorry, in the x-axis, there should be a frequency or a number of students, and the y-axis it should be class interval. Okay, now the scale of the, now here number of frequencies 5, 10, 15, 25, 35. 5, 10, 15, 20, 25, 35. So the scale here we will write the scale along the y-axis. Here in this side, axis is how much? We think that this two group 1 centimeter equal to 5 students. Let's consider 1 centimeter is equal to 5 students. So we will write here 5, 10. We think that up to from here to here it's 1 centimeter. Okay, now 15, 20, 25, and the last one is 35, because up to 30 students are there. Oh sorry, it should be 30. So this is the base is a mark of the student, that is class interval, and this is a number of student, that is a frequency, and this is a scale along the x-axis is 1 centimeter is equal to 5 students. Okay, now first we have to draw 10 to 20. Now what up to 10 to 20, how many people up to 10 to 20 students marks 5 students are got. So we have to draw up to 5 here from 10 to 20. Okay, we have to draw up to this 10 to 20. The next one is from 20 to 30, means 20 to 30 is up to 10, up to here. So in there is no gap between rectangles, this bar, so we have to touch each other. So we have to draw up to 10. Up to 10 student got 20 to 30 marks. The next one is 15 student got 30 to 40 marks. Okay, almost 15 student. Here 15 student got up to. Now Next is 40 to 50 students got 25 marks. Up to 25 marks. We have to draw up to 25 marks. Same thing that we have drawn the bar graph. Okay. And the last student is 60 to 50. 60 to 50 is 30 students. 30 students are getting up to 60 to 50. This is the histogram. Okay. This is the histogram. This is the histogram. Here, so it from 10 to 20, 0 to 10, there is no 0 to 20, 0 to 10, because the indication of the distance between 0 to 10 is not shown completely. So we have to put a clean here, zigzag. Understand? Now this is a bar graph. This is a histogram. See, in case of bar graph, there is a gap between its bar graph. It's rectangle. But in case of histogram, there is no gap between. So all the rectangles should be touch each other. This is how we have to draw the bar graph. And again, now we are going to answer this question. See, look here. According to this graph, we are going to answer the question. What is the class size? But the first one, the class size. Now this is a graph. Okay, this is a histogram. Histogram is completed. Then now we are going to answer the following question. The first one, first answer. What is the first answer? What is a class size? What is a class size? Class size means what? Means upper limit class minus lower limit class. You can take any one. Upper one is 20. Here is 20. Okay, minus 10. What is a class size? Class size is 10. 10 is a class size of this given frequency table. Okay. Now the second one is question number 2. Which class has the highest frequency? Let's see. Which one is highest frequency? 50 to 60. Right. 50 to 60 is the highest frequency because it has 30 students. So the highest is 50 to the class interval of here 50 to 60. 50 to 60 has highest frequency. Okay. Next, the last one. Question number 3 is find the class mark of this interval. Class interval. You have to find out the class mark of this class interval. What is the class mark? We have already discussed about the class marks. Class mark is a midpoint of a class. Okay. It is obtained by taking the means of upper class, upper and the lower class limit. Now, in here, from here we have to take the class mark. The class mark for this class interval. Here, what do you mean by class mark? Of we have to take the class mark for the class interval of 50 to 60. So what is a class mark? Class mark, it is a midpoint of the class. Means the midpoint of these two. What is the midpoint of these two? The midpoint means the middle of these two is 55. How to find out? What are the process to find out the class mark is to obtain by dividing the upper. Upper is, which one is upper? 60. Min plus lower is min of upper and the lower, and divided by 20. This is how we are going to find out. The answer is 110. So if you divide by 2, your answer will be 55. This is a class mark of the class interval 50 to 60. Okay, let's see how to find out the reading and interpreting pie chart. You have learned how to this is how to construct. Before we learn how to construct the pie chart, we have to discuss this first. Now before we start the now this is the construction of pie chart. Okay, see, complete, this one is a complete angle at the center of a circle is 360. An angle of 180 at the center is the angle extended by the semicircle. A quarter angle extended the angle of 90 degree at the center. This is a complete angle. This is a semicircle. This is a quarter circle. These are all form of sectors. In the sectors, we are going to put in this way. So the construction of pie chart. Let's discuss the construction of pie chart. Add up the various part of data and get the total value. First, we have to add up all the, see, look here. This is the data. First, add up the various part of data and get the total value. We have to add up all the total data, and here is a total is 24. Divide the value of its part by the total and multiply by 360 to get the sector angle for its part. Means here you divide this by total part, that is 24, and multiply by 360. A circle, and draw a circle and its radius to be coincide with the position of the overhand of the clockwise. Identify the part with the largest shear and hence the largest central angle. Now construct sectors such that one of the radii that is a boundary is the one in the step 3. Go in a clockwise. We have to construct, we have to draw measure the degree central angles in the clockwise direction. Similarly, construct other sector going in the clockwise direction with the corresponding central angles. Label is sectors. By convention, part like miscellaneous or other are present in the last sectors. This is how we are going to find out the central angle first. After finding the central angle, we have to draw the pie chart. So this is a formula that we have to learn how to find the central angle. We have just learned how to construct a pie chart. We have learned how to construct a pie chart when the value of the part of the whole were known. To read the pie chart means to find out what part of the whole does each sector represent. Okay. To find a central value, we use the formula for central angle. That is particular part. Particular part is the value of the part. This one is the data. Okay. Total of all part. Total of all part means you have to add up all the particular part of the total, that is 24, and then you have to multiply by 360. This is a formula how you are going to find out the central angles to construct the pie chart. And again, and another how to find the particular part. Means particular part is the given data. How will you find the given data? To find a given data, we have central angle into central angle multiply by total of all the part divided by 360. If you want to find out the particular part, means that is its data, then you have to multiply central angle into total of all the part and divided by 360. These are the two formula that we are going to use to construct pie chart. If you want to construct a pie chart, then we have to find out the central angle, and if you want to find out the particular part, you have to use this formula. So let's see one example how to find out central angle and how to find a particular part. This is an example. Out of total of 108 workers, 420 workers belong to category A, 300 to the category B, and 225 belongs to category C, and 135 categories belongs to D workers. draw a pie chart to represent this information. This is the total workers. So we can prepare one small table here. Category numbers of workers. We can prepare one table here. Category A is how much? 420. Category B is 300. Category C is 225. Category D is 135. Now the total numbers of workers is 0, 5, 6, 7, 8, and 10. This is the total number of workers. Means this is the total of all the parts, and these are all the particular parts. So first, what we have to do is we have to find out the central angle of the sector to represent this part. So first, this is the solution. Where is the solution comes? The central angles for sectors to be represented by this part. This part means these are all part. Okay. Then first one, to find the central angles, we have to write the formula. Central angle is equal to particular part divided by total of all part into 360. This is a formula that we are going to find out the central angle. Now first we have to find out central angles for category A. For first category A, category is particular part is 420, total part is 108 into 360. So this is here. Then what will be the answer? If you cut this 0, 0, you can omit 0, 0. Then this can be divided again by 2, 1, and 8. This can be divided by 2, 5, 4. Again, this can be cut by 6 again, 6, 3, 6, 9. And this will again cut by 3. Now, 420 by 3 is 140 degree. The first category sector, to draw the category A, the degree is 140. Now, category 300 divided by 1080 into 360. Now you can cut 3, 3. Same thing, this will be 3. Then answer will be 300 divided by 3 is 100 degree. Now category C. Category C is 225 by 1080 into 360. If you cut this 0, 0, you divide by 3. 225 by 3. The answer is 75 degree. The last one is category D. Okay, but part of the category D is 135 divided by 1000 and the total part into 360. Cut this 3. 135 divided by 3. The answer is 445. So there are 4 central angle degree we got from category A, B, C, and D. Now we are going to draw an central angle, means we are going to draw a pie chart. According to this central angle, we are going to draw a pie chart. To draw a pie chart, what we are going to do is that we have to draw a circle first. Let's see. Now let's draw the pie chart. First we draw a circle, and then again we draw the radius of the circle. Yeah, this is the radius, and with halo protector we have to draw the central angle of category A, that is 140 degree. Now let's draw the 140 degree by using the protector to make the sectors of the category A. Here is 140 degree. Okay. This is category A. The next one again we are going to draw in category B. Here is a category B. Here is category B. Okay. This is a category part of the category B. The next one is category C, that is 75 degree. Where is 75 degree? Here is a 75 degree. The last part is a 45 degree. Let's see whether it is 45 or not. Yes, this is a 45 degree. So this is how we are going to draw the pie chart. This one is 140 degree. This is for category A, portion for category A. This is 100 degree for category B. This is 75 degree for category C. This is 45 degree for category D. You can set by different pattern also, no problem. Okay, you can set these sectors by using by different patterns. This is the pie chart. To draw the pie chart, first what we have to do is we have to find out the central angle of the given data, and then after finding out the central angle, then we have to draw a circle, and then after that radius, and by using the protector we have to we have to put the degrees of the its central angles to make the sector of given data. This is how pie chart is constructed. The next one is, let's see the another one question that is about the how to find out the particular part. This is another question to find out the particular part. That is the data of the this given pie chart. Say a day's sales at a bookshop was rupees 1440. This includes sales of school books, friction, non-friction, and also the college book. As shown in the pie chart, how much did each of this category contribute towards the sale of rupees 1440? This is a pie chart, and this is a central degree for each of the category. That is school book 135 degree, friction 100 degree, non-friction 80 degree, and a college book 145 degree. We have to find out how much each of this category contribute towards the sale of rupees 1440. So we are going to find out the rupees, that is particular part. Now total is already given and the central angle is already given. So for solution is that particular part, there is a particular part is equal to what? Central angle into total of parts divided by 360. This is a formula to find out the particular part. So the first one, that is school book. Central angle is 135 degree into part is 1440 divided by 360. Now you got this 2 and 7 2. This will be 118. Then this will come to 18 6 18 18 4 18 4. Yes, 4 rupees 135 into 4, that is rupees 0 12 14 no, rupees 100, sorry, rupees 540 is the part of the school book. The second one is friction. Friction is 100 into 1440 divided by 360. So you got this, your answer is 4. So rupees 100 into 4 is rupees 400 is the part of friction. And another, the fourth one is non-friction. Non-friction is 80 into 1440 divided by 360. So you cut this by 4. Then answer is 80 into 4 is equal to 300 rupees 320. And last one, that is college book. Particular part of college book is 45 into 1400 divided by 360. Look at this, 4 rupees 45 into 4 is equal to rupees 180. These are all a part of rupees of particular part. This 5400, 5040, 400, 320 and rupees 180. Now does contribution, let's see, contribution of various category was as follows. We are going to check whether we are getting 1440, 450 plus 400 plus 320 plus 180. What is the answer? 0 0 0 0 8 10 14 4 1 carry 1 3 9 10 13 14 rupees 14. So the contribution for towards a sale of rupees 1440 is rupees 540, rupees 400, rupees 320 and rupees 180. These are all the particular part of the sales of rupees 1440. So these are the two examples. The first example is pie chart, how to draw the pie chart, how to find out the central angles and how to draw the pie chart. And another one is after giving the central angles and the total, we are finding the particular part. This is the particular part, how to find out the particular part after central angle and total part are given. Okay, these are the two important questions for the pie chart. So thank you, student,